delving into lesson 76, and we are integrating with sine and cosine, specifically when there are odd powers. Okay, give us a couple of lessons and we will integrate with even powers of sine and cosine. Right now we're just talking about odd powers. And so, first thing you'll notice up there, we're going to use the identities. 1 minus sine squared x equals cosine squared x, and 1 minus cosine squared equals sine squared x. Do you guys realize what identity that's coming from?
Sine squared plus cosine squared.
Yeah. Sine squared x plus cosine squared x equals 1. Okay, that main Pythagorean identity can be changed into either of these as others, correct? So the idea is how to integrate as you look at these, like this first one is just sine cubed. How do you integrate something that is sine cubed? Because we know when we start talking about a sine, and whether it be derivative or integral, we're going to throw a cosine in. And with this being a power, we're going to have a chain rule. So that's kind of what we're looking at here. So example 1, sine cubed x dx. If we looked at this right now, an integral of something to the third is something to the fourth. However, the problem with this one is because it's a sine, we would do that chain rule, we'd have the cosine in there, and that's not covered here. So, first thing we're going to do is we're going to take sine cubed, and we're going to split it. And we're going to split it so that sine squared is one of the pieces, because sine squared will be able to replace. So I'm going to split this into sine x times sine squared x. So you always want to split off even powers there. Using our identity, sine squared x can be replaced with what? 1 minus cosine squared x. So now I'm going to have the integral of sine x times 1 minus cosine squared x dx. Yep, we're going to distribute next. We're going to distribute next so we have two integrals to work with. So when I distribute, sine x times 1 is sine x minus sine x times cosine squared x is minus sine x cosine squared x dx. Excuse me. Officially, I have two pieces being subtracted. So those two pieces being subtracted basically can be integrated individually. Not saying you have to write it out in two separate integrals, but I'm going to for the purposes of what we're doing today. So one integral we're going to have is the integral of sine x dx. Minus, and then we're also going to have the integral of sine x cosine squared x dx. Excuse me. Start with the first one. Integral of sine x. Negative cosine x. Basic rules we already know, yes? And then we know it's going to be minus, and then some integral, yes? Okay, guys. Use substitution, or I'm trying to think of what's the best way to call it, but think in terms of use substitution, I guess is what I'm going to say. In that, what is our main thing here? We have something raised to the second, yes? So that something raised to the second, that something is cosine. So I would use that as my u value. So if u is cosine x, then what is du? In other words, if u is cosine x, the derivative of u is du, so the derivative of cosine x is negative sine x dx. So think about all my pieces covered here. Cosine squared x is going to be the idea of u squared. Because if u is cosine, and this is u squared, what else do you notice here? We need a negative sine x dx. Well, what do you have? Here's dx. There's sine x. And officially, do we have a negative there? Kind of, except that I've already put that minus up there. So the key is everything covered? Everything's covered. You have to do this one of two ways. So what is this really going to be? It's going to be the integral of u to the second du. Now, I can either put another minus here or go back and make this a plus. Does that make sense? Because the idea here is we had a negative here, we had a minus here already. So a negative and a minus. There's the negative that was there already. Here's the minus that was here. It's going to essentially become plus. What is the integral of u squared?
U to the third over 30.
Add a power and divide by that new power. So Wade listed it as u to the third over 3. Or you could say 1/3 u to the third. I'm not picky. Me personally, I'm going to write 1/3 u to the third. So what do we put back in for u, though? Cosine x. So if I carry down the part we already have here, it's negative cosine x plus 1/3 cosine cubed x and plus c. We're integrating, so we've got to remember a plus c. Questions there? Should I take that as a no? We're ready to try example 2? Okay. Well, if you look at example 2, the only difference is it's cosine cubed. We're going to be doing the same process, so it's a good way to practice the process. Okay, so what do I want to do? Cosine cubed is an odd power. I'm going to split it into a first and a squared, right? So it's the integral of cosine x times cosine squared x dx. All I've done is rewritten cosine cubed as cosine times cosine squared. The whole point of splitting off an even is that cosine squared can be replaced with one minus sine squared. 1 minus sine squared x, and then dx. Need to distribute. So if we distribute, and actually, I'm going to go ahead and distribute and break it up into two integrals at once. Are you guys okay with that? So if cosine x times 1 is going to be the integral of cosine x dx minus the integral cosine times sine squared. is cosine x sine squared x dx. Excuse me. Okay, you ready? Integral of cosine x. Sine x? Because the derivative of sine x is cosine x, right? So the integral of cosine x is sine x. Now, I already have a minus sign. So minus. And as you get better with these, you may or may not have to use the u substitution. Needless to say, the sign, because that's what's raised to the second, right? So, in other words, that's going to be u squared. So, if u is sine x this time, then du is the derivative of u. And what's the derivative of sine x? Cosine x dx. Okay. Match your pieces up. Does it match? Du, when I replace, what am I replacing du? Cosine x dx is replacing with du. So in this case, my minus sign is just fine as is. So there's the minus, it's already there. And I'm going to do the integral of u squared, is that sine squared, and then cosine x dx is represented by du. What's the integral of u squared? U to the third over 3. Feel like you just did that? I wrote 1/3 u to the third. Either way. So, carry down your sine x minus, it's 1/3 u to the third, except what was u? Sine in this case. So 1/3 sine cubed x and plus c. Okay. Ready for the next one? Integral of sine to the fourth x cosine to the third x dx.
You can split the cosine again.
Okay.
This time you'll have to distribute a sine to the fourth times cosine.
Right. Okay, so
Sine also.
you don't want to. Not saying you couldn't, but it's not worthy. Okay, so then the question becomes is, how do I know to split the cosine? Okay, what is our lesson about today? Okay, so for the purposes of today, our lesson is about integrating odd powers. And so when you have an odd power and an even power, then our default is going to be to split the odd and leave the even as is. It will work out. You just have to give me the chance. Okay, so we're going to split the odd when you have an odd and an even. We will, as I said, it's, I don't know, a couple lessons down the road somewhere we talk about integrating even powers. And in other words, when there isn't an odd power, what my options are. So, but for today, let's stick with this. So if we keep the sine to the fourth then is what we're saying. If we're splitting the cosine cubed, we're going to split it into a cosine squared x and a cosine x. And there's still a dx. And the idea is I haven't changed the value here, right? I've just rewritten cosine cubed as cosine squared times cosine to the first. So now, what is it that I can replace here?
Cosine.
Yeah, and I put it in the middle. I don't know if the middle was the best place. I wasn't thinking about that one. Sine to the fourth is still sine to the fourth x. Am I going to throw you guys for a huge loop if I go ahead and move the cosine x up front? I'm going to go ahead and move the cosine x. I'm just trying to set us up nicely for the next step. And then, what is cosine squared being replaced with?
1 minus sine squared.
1 minus sine squared x. So I just flip-flop those two pieces, right? Now, as in the past, what is our next step? Oh, yes.
Will we always need to use these up here or down here, or do we need to know when to use them and not to use them with these kind of problems? Because when we first learned the identity ones from the program paper, sometimes we didn't use them, sometimes we did.
I don't understand. I mean, are you saying do we need to know like the sine squared plus cosine squared equals 1?
No, never mind. I'm guessing that if you don't understand my question, then the answer is probably yes.
Okay. I mean, if you're asking, are we always going to have to use them? I mean, the key is you're going to have to use them in this situation when we have these odd powers. Okay. I mean, it's a little bit easier if you're just integrating like a basic sine or cosine, but when we throw these powers in, we have to be able to deal with chain rule and whatnot. So, I mean, we're always using them today if that, helps. Okay. So what are we set to do at this point? Distribute, right? We're going to distribute this, and we're going to end up with two separate integrals. When I distribute, realize you're taking sine to the fourth x cosine x, and we're distributing it to the 1, and we're distributing it to the sine squared. So, sine to the fourth x cosine x times 1 is just going to be sine to the fourth x cosine x, and then, of course, times dx, if I go ahead and split it into two integrals. And now there's my minus. This time I'm taking sine to the fourth x cosine x, and I'm multiplying it by sine squared. So what's my sine power now? I'm going to have sine to the sixth. We still have a cosine x and a dx. Are we okay with what I have right there before I continue? No. Okay. What are you not liking?
The last step where you got sine to the sixth cosine x.
Okay. And it's because I took sine to the fourth cosine x. I took that term. First time we distributed by 1. The next time we distribute it by sine squared.
So why don't you have the sine 4x cosine x minus, then you do the next one. If you're timesing it by 1, wouldn't it still go over there?
Like sine to the fourth x cosine x minus sine to the sixth x cosine x.
That is what I have.
You split the derivative.
Oh, you already. Oh, I see what you're saying. You already like split them. That's why I was like thinking.
Okay.
I was thinking you just brought that down and then you were timesing across.
No, I'm sorry. I split the derivative the same. Maybe I shouldn't have here.
Well, now
Sorry.
I get it, but at first I was like, you didn't times it by 1.
And I swear I have exactly what Wade just says, but he still has a confused look on his face. So I'm not sure where it's. Okay.
That first section is the one that was multiplied by the 1. The second section is the one that was multiplied by the sine squared.
So we took sine to the fourth cosine x as one thing, one term,
The 1
times the 1,
there.
and that's right here. Sine to the fourth cosine x, and I went ahead and split it up. Obviously, this was a bad idea.
I
Sorry.
get it now.
Yeah.
Okay. And then, so my minus sign carries down, and now it's the sine to the fourth cosine x times the sine squared. Sine to the fourth times sine squared is sine to the sixth, and then the cosine x. Sorry. I kind of thought I was okay. Obviously, I thought wrong. Maybe I won't split up next time to make up for it.
So I was thinking like I had kept the sine to the fourth x cosine x and tried keeping that, but also multiplying it. So I was getting two of that same number. That's what I was
Okay.
doing.
Okay.
I see. I don't need the first one since we're multiplying it.
Other questions? Who else have I lost? And what do I need to do here? Operator, is there any explanation you need? No? Carly? Okay. I'll be more careful next time. I definitely will be more careful next time to try and, it's hard to go back once you've done something. So all I can say is next time I'll take it more carefully at that point. Okay. Now, what we have at this point is we have two integrals. We kind of have to use the u. What's u going to be in both cases? The sine x. What's raised to the power? Okay. So in both cases, and I'll write it out over here, I'm going to use u as sine x. Because here it's going to be a u to the fourth. Over here it's going to be a u to the sixth. If u is sine x, what is du? So if u is sine x, the derivative of u is du. The derivative of sine x is cosine x dx. So if we rewrite this, we have the integral. Sine to the fourth is u to the fourth. What about cosine x dx? What represents cosine x dx? Du. Minus an integral. We have sine to the sixth x, which is represented by u to the sixth. What represents cosine x dx? Cosine x dx is du. So, what's the integral of u to the fourth? U to the fifth over 5. Minus, what's the integral of u to the sixth? I'll take it either way. U to the seventh over 7, 1/7 u to the seventh. It's the same. And honestly, I like talking about both because you need to recognize both. So what do I do to finish this up? My original problem was in terms of u. My original problem was in terms of x. What do we know u was? Sine x. So 1/5 sine to the fifth x minus 1/7 sine to the seventh x. Did anyone say it? I was going to say, or did you just see me write it? But technically, I wrote it off the screen, so you guys didn't even see it. Okay, ready for the next one? Sine cubed x cosine to the seventh x dx.
The small one.
Okay. And I'm not going to say you couldn't do it by splitting the bigger one, because I think you could. But the advantage of splitting the sine cubed x is we can split it like we have. And what we want is we want one extra of something. We don't want a whole bunch of extra. So like if we split off a cosine squared here, we don't want 5 extra of something. Okay, we just want 1 extra of something. And so by splitting the sine cubed, we can get that.
So we're not splitting both.
No, we're just going to split 1. Okay? So if we just split 1, we're going to split the smaller one. So sine cubed can be sine squared x times sine x, and then still cosine to the 7th x. What am I going to replace? The sine squared, the even. So now, sine squared is going to be in parentheses 1 minus cosine squared x, still times sine x, still times cosine to the 7th x, dx. Should I distribute and then separate integrals this time?
I think.
I'm hesitant to. So realize, what is it I'm distributing this time? And maybe I need to flip it, I don't know. Sine x cosine to the 7th x is what's being distributed. So when I take sine x cosine to the 7th x and I multiply it by 1, I'm just going to have sine x cosine to the 7th x. Should I continue my integral or should I split my integral? We think we're okay this time? Okay, so then I'm going to end that integral with a dx. Now minus. So the first time we distribute it to 1. This time we're going to distribute those two terms to cosine squared. So if it's cosine squared times sine cosine 7th, I'm now going to have the sine x and a cosine to the 9th x dx. Where do I need the u? On whatever has the power, yes? So I'm going to use u as cosine x. If u is cosine x, then what's du? Derivative of cosine is negative sine x dx. So cosine to the 7th x is really u to the 7th. Cosine to the 9th x is u to the 9th. What do you notice about this first one? Yeah. It's a negative sine x dx. I just have a positive sine x dx. So if you divide this negative over, it's negative du equals sine x dx. And the idea then is, what am I replacing sine x dx with? Sine x dx is being replaced with negative du. And then minus. Over here, we've got u to the 9th. Sine x dx gets replaced with negative du. Or you can go put that negative out front. Okay. So, you're integrating, it says u to the 7th. Really, we need to think of it as negative u to the 7th. What's the integral of negative u to the 7th? Negative u to the 8th over 8. Now in this next one, it's minus, and there's a negative in there, so I'm going to turn it into a plus. You're integrating u to the 9th. 1/10 u to the 10th. Plus c. And you're filling in what was u? Cosine x. So negative 1/8 cosine to the 8th x plus 1/10 cosine to the 10th x plus c. Lots of integrating practice. We're going up in powers. And we're remembering those plus c's. Okay, guys. One last one. So, we have a sine squared x and a cosine to the 5th x.
Would it be the rule of 1 minus cosine squared x times cosine squared x times cosine squared x times cosine x? Or is there a better way to write it?
Well, here's the deal. As much as you want to replace that sine squared x, if you try and replace sine squared x with 1 minus cosine squared x, notice everything in my problem is now cosines. And that doesn't allow for a chain rule option. We need a mix of sines and cosines when we're talking powers. So, what we're going to do, as much as we want to, it's already a nice sine squared, I just want to replace it, we're going to have to pull off, we're going to have to use the cosine to the 5th. Now, the key is, I only want one cosine hanging out in the end. I don't want 3 cosine hanging out in the end. So the trick here is that we're going to keep the sine squared as is. We're going to break this cosine to the 5th, kind of like Wade, what you were saying, where I'm going to do a cosine squared, and then a cosine to the 1st. Both of those cosine squareds are going to be replaced with the 1 minus sine squared. Okay? Now, I was going to write that slightly different. However, I can keep it as is if you want. So if we think sine squared x, when I say cosine squared times cosine squared, what if I try and write this as cosine squared raised to the power of 2? Let me write it and see what you guys like. So cosine squared x, then that quantity squared, and then there's still a cosine x dx. Take a moment and take that and see if you, I haven't changed anything. It's still equivalent. Because as I said, in the end, we only want something with a power of 1 to be left different. So we're going to end up with everything else in sines except this cosine to the 1st, which will be my chain rule. So do you see how I still have cosine to the 5th? It's basically, if you prefer, cosine squared times cosine squared times cosine. So now, replace cosine squared. What are we replacing cosine squared with? That is replaced with 1 minus sine squared x. So it's 1 minus sine squared x, quantity squared. If you prefer, and you would have rather have done cosine squared times cosine squared, then you would have 1 minus sine squared x times 1 minus sine squared x. If that's more your comfort zone. Okay? Because, what do I have to do in this next step?
Separate.
I'm not ready to separate them yet. Those two have to be FOILed, which is why I wrote that up there on the board there. So my recommendation, first of all, what do we have here outside of that FOILing? A sine squared and a cosine, correct? I'm going to pull those two and put them at the front, or put them next to each other. So I have a sine squared x, cosine x. And then I'm going to FOIL. 1 minus sine squared x. So as we start FOILing, 1 times 1 is 1. 1 times minus sine squared, and another 1 times minus sine squared is minus 2 sine squared, because it's minus 1 sine squared minus 1 sine squared, minus 2 sine squared x, and then minus sine squared times minus sine squared is sine to the 4th. In my parentheses, input a dx. Now, what am I ready for you to do?
Now we distribute.
Now I'm ready to distribute. Take this sine squared cosine x, and we're distributing. How many things are we distributing it to?
3.
3. So, am I safe to go ahead and break this up into 3 integrals along the way? You see how I'm doing this? And so, my first integral is me doing sine squared x cosine x times 1. Sine squared x cosine x times 1 is just going to be sine squared x cosine x, and of course, as always, dx. My sign that goes in between my next integrals is a minus. What about this whole number 2? Can we go ahead and pull that 2 out front? It's a constant. So I'm going to do 2 times the integral. And I'm doing sine squared cosine times that sine squared. What's sine squared times sine squared? Sine to the 4th x cosine x dx. My sign in between my next integrals is a plus. And this time we're multiplying sine squared x cosine x into sine to the 4th x. So sine squared times sine to the 4th is sine to the 6th x cosine x dx. Okay, almost there. Notice the consistent setup. They are all sine to some power, right? With a single cosine x dx left over. So if you still need, and some of you can probably write your answer from right here. Go for it. That's fine. But if you need the visual, what is my u? My u is, no, my u is whatever has the power. So u is sine. Because then du, what is the derivative of sine? And that is cosine. So think about what I'm integrating on all of these. This first one is the integral of sine squared, so this is going to be the integral of u squared. What's cosine x dx replaced with? Du. Minus 2 times the integral on the next one. The integral of sine to the 4th, you can rewrite as u to the 4th. Cosine x dx is the same as du. Plus sine to the 6th, I can rewrite as u to the 6th. Cosine x dx is du. What's the integral of u to the second? 1/3 u to the third. What's the integral of u to the fourth?
Well, u to the fifth over 5, but then put the minus 2 in also.
Okay, so if it's u to the fifth over 5, or what I would say 1/5 u to the fifth. If it's 1/5 u to the fifth times a 2, it's really going to be 2/5 u to the fifth. And then the last one, the integral of u to the sixth, 1/7 u to the seventh. And you don't necessarily need to write those integrals in right there. You know, maybe if you realize 1/3 u to the third, could you go ahead and sub your sign back in? Okay. So 1/3 sine to the third x minus 2/5 sine to the fifth x plus 1/7 sine to the seventh x. And plus c. Notice, I don't know, I didn't talk about the beginning of class how you guys did on the change up in homework. First of all, did you do lesson 75 and skip lesson 74? And second of all, did you remember the switch? In this one, there's just one problem it appears it's switching. When you get to number 2, it'll be a problem from lesson 74. We don't know how to do lesson 74, so when you get to number 2, you're going to go back and do number 2 from lesson 74 in its position. Okay. Okay. So you might have this problem done if you started the wrong lesson last time.
So for number 2 on this homework, it's the problem from problem set 74.
Number 2, yes.